Okay, welcome back. This is grade 9 Applied Math, Unit 7, Lesson 3, Compound Perimeter. I'm just going to draw your attention to, if we were meeting face-to-face, this is the handout you would be given. There is a link to this in the LMS, so if you don't have this handy, you might want to pause the video now to go get it. I'm going to move to the Smart Notebook file, and then we'll just talk about the first question. So Polly's dad is going to fence in a play area for a backyard, trying to determine the total amount of fencing he needs. Which of these two calculations down here would be the correct answer? I'm going to pause so you can think about it, and I will also be thinking and writing at the same time. All right, taking a look at what we've got written here, this is really 2L plus 2W, and this is L times W. So my units here are meters, because this would be meters right here, there would be meters here, and that would give me units of meters, but we'd have meters here, and we'd have meters here, and meters times meters would be meters squared. So this one's actually returning an area. So the correct calculation would be this one. All right, on to the next slide. A length of cord is wrapped around a circular spool 12 times. The diameter of the spool is 10 centimeters. So they're telling you that right across here through the center is 10 centimeters. And to make this problem easier, what we're going to presume is that it's been wrapped around here 12 times, but with no overlap, because that would be a more difficult problem, because then the radius would be changing. So the first thing you're going to do is you're going to figure out how much cord is there. And remember, we're wrapping around a circular, so you need to be a circular surface. So you have to be using the formula for circumference of a circle. All right, I'm going to pause, you can do some work, and then I will do some work. And in addition to finding the perimeter or circumference, you're also going to have to think about how much cord there is, because it's going around 12 times. All right, coming back to discuss our solution, there are two formulas we could be using for circumference of a circle. One is pi d, and the other one is 2 pi r. I'm choosing to use pi d because they gave me the diameter. So the circumference would be pi times d. That would give an exact answer of 10 pi. If I want to round that, notice I put the approximately equal symbol above the equals. So the circumference is approximately 31.42 centimeters. Now it goes around 12 times. That's around just once. If it goes around 12 times, then over here I'm noting I'm going to need 12 circumferences. That's why I put a 12 in front of that. And 12 circumferences would be 12 times 10 pi, which is 120 pi, and then punching that into your calculator, the approximate answer, and again making use of the dot above it, is 376.99 centimeters. All right, now part 2. The cord is going to be used to make bracelets. Each bracelet requires 20 centimeters of cording. How many bracelets can be made from 3 spools of cording? So to get you thinking, this is the amount of cording in one spool. You don't have one spool, you have 3 spools, and then each bracelet will use 20 centimeters of cording. So I'm going to pause so that you can do some work, and then I'll be doing some work simultaneously. Okay, so the first thing I'm going to do is I'm going to figure out how much cording I have altogether in 3 spools. The amount of cording in one spool is right there, 120 pi. If I have 3 spools, it's 3 times 120 pi. So the exact amount of cording is going to be 360 times pi. That's approximately equal to 1,130.97 centimeters. If each bracelet uses 20 centimeters of cording, then what I'm going to need to do is divide the total amount, which is right here, by 20. Because how many times does 20 fit into 360 pi? 360 divided by 20 gave me 18, so the exact answer would be 18 pi. You could punch this into your calculator if you're not comfortable with doing that other simplification. And this answer is approximately 56. In this case, I rounded down because we can't make half of a bracelet or a third or a tenth of a bracelet. We have to make a whole number, and we only have enough material to make exactly 56 bracelets. All right, the next question. If the bracelet is sold at a fundraiser for that amount, how much money will be raised? And again, pausing so we both can work on this. All right, so 56 bracelets. Each bracelet, we're charging 75 cents for each bracelet, or $0.75. So then I'm going to multiply 56 by $0.75, and I'm going to get $42. Okay, next problem. You need to install fencing around this playground. How many linear feet of fencing will you need? You should probably pause at this moment to do some thinking about it, because I'm going to give you a hint in a few seconds. So if you don't want to hear the hint early, pause now. All right, so the fencing is going to have to go around the edge like this. Let's go like that, and then like that. So we have this measure. If I bring this down like that, then you should know what the distance from here to here is. It is isosceles right, so that will tell you what the distance here is, because these two sides were equal. So the part you're not going to be able to find right now is this piece here. How are we going to find this piece here? So I would like you to notice that sitting right here is a right angle triangle. Man, it's not so easy to draw on this with a trackpad. Alright, never mind. Let's just pretend that's a straight line. Alright, there's a right angle triangle here, and you can use the Pythagorean theorem to find the length of that side. So that's the hint I'm going to give you. Pausing so that we both can work on the full solution to this. Okay, so we're back to fully discuss the solution now. So we did mention in the beginning that we would have to use the Pythagorean theorem. When I paused, I erased this and I used a straight line tool to draw the lines here. So I'm trying to find the hypotenuse, and this is the hypotenuse over here, because coming off the right angle, it points to this side here. I'm going to note that x. The Pythagorean theorem says h squared equals a squared plus b squared. Plugging in my hypotenuse as x, and it doesn't matter in which order I plug in the legs, 12 or 5, I'm going to get x squared equals squaring 12, 144, squaring 5, 25. X squared equals adding these two numbers, 169. Undoing squaring by square rooting, x is the square root of 169. That's a perfect square number, and the square root of that is exactly 13. Now for the perimeter. I'm heading around here. You can see we have 14 here, and there's 14 there. So I noted two 14s. There are also two 13s, one here and one right there. And then there are also two 5s. So that's what I noted here. Two 13s, two 14s, two 5s. Doubling 13, 26. Doubling 14, 28. Doubling 5, 10. Adding all of this together, we get 64. And then I write my conclusion. Therefore, 64 linear feet of fencing will be required. All right, next problem on, perimeter, compound shapes, etc. It now says if fencing costs $5.25 per linear foot, how much will it cost? And now we need to include the GST. And just taking you back to this particular slide, we've determined that's how much fencing we're going to need. So now I'm going to give you some time to figure out what is the total cost, including taxes, that you're going to pay for that fencing. And again, we both should be pausing to do some work at this point. All right, discussing the solution now. On the previous slide, we determined that we would need 64 linear feet of fencing to come completely around that. Remember, the perimeter is coming just around like this and like this. You're not to include that piece because it's not on the perimeter. So we determined the perimeter was 64. Each linear foot has a cost of $5.25. So 5.25 times 64 will give me the total cost of the fencing. Now that works out to $336. Now I'm going to have to pay HST, the harmonized sales tax, on that. So to find the sales tax, I'm going to multiply 336 by 0.13, because 13% is 13 out of 100. and that will give you 0.13. That's where that's coming from. When I multiply those two together using a calculator, I will get 43.68, so $43.68. That's the amount of tax I have to pay. The total amount I'm going to pay would be $336 plus $43.68 for a grand total of $379.68, and then write a conclusion off to the side. All right, let's see what's coming next. So Andy doesn't think it's possible to find the amount of baseboard that you're going to need. So his den is kind of an L-shaped room. Do you think he has enough information to figure out the perimeter of this den? Because that's where the baseboard is going to go. I'm going to pause so that you can think about that. And you should be pausing too, otherwise that won't be useful. Okay, there is enough information to figure this out, right? I'll just show you the same distances. Traveling along here would be the same as traveling along here and along here. And then traveling along here and here would be the same as traveling along here. So that's enough information for you to figure out the perimeter. So I'm going to pause, and you should pause so that you can actually figure out the perimeter. Okay, so again, this distance and this distance is the same as this distance, so I'm noting I'm going to have 2 at 2.2 plus 1.8. And we're also going to have 2 along the green distances here. That distance and that distance appears twice. So 2 at 1 plus 4.1. 2.2 plus 1.8 is 4. 1 plus 4.1 is 5.1. Doubling 4, you get 8. Doubling 5.1, you get 10.2. Adding those together, we have 18.2 meters of baseboard altogether that's required. All right, let's move on to the next slide. We know we said, let me just write this down for you. We were at 18.2. The baseboards are coming in 3.2 meter lengths. How many pieces will you need to buy? And this is what Home Depot is charging, plus that for delivery. That's what Lowe's is charging, free delivery. But they're offering a 15% pre-tax discount. Where should Andy buy the boards? So I'm going to pause to let you think about that. Okay, so let's take this one up. So we had calculated up here, actually I jumped forward a bit too far. We had calculated that we need 18.2 meters of baseboard. And over here, if the boards come in 3.2 meter lengths, then I need to know how many times 3.2 goes into 18.2. So I did that division, and that was 5.6875. But you're not going to be able to buy part of the piece. So let's presume you have to buy the whole piece. So I'm going to need 6 pieces. So 6 lengths of baseboard. And there wasn't enough room here for me to continue working. So I went to a new slide to do this work. So we need 6 lengths. Home Depot is charging $9.52 per board, as written here. That's going to give me a total of $57.12. But then I'm going to have to add on $15 for delivery. $15 for delivery. $57.12 plus 15 is $69.12 right there. And then I'm going to have to figure out the tax. And the tax, HST is 13%. Our harmonized sales tax. So 13% of $69.12 is $8.99, and then the total would be $69.12 plus $8.99. So there's the total cost for Home Depot. It's going to be $78.11. At Lowe's it costs more, but there is no delivery. So let's see what difference that makes. Again, 6 boards at $14.50 per board. Multiplying those two together, I get 87. There is no delivery, and now I have a discount. And the discount's 15%. So I'm going to multiply 87 by 15%. I get 1305. I'll subtract that. CD is the reduced cost, or the cost with the discount. 87 minus 1305 is 73.95. And now I'm going to have to add the tax. All right, so that's my sort of subtotal. 73.95 times 0.13. Actually, that T is for tax. 73.95. 0 times 0.13 gives me 961. And now I'm going to add the tax back to 73.95 and that gives me a total of 83.56. So Andy should buy the boards at Home Depot, unless Lowe's happens to be fairly close to his house and Home Depot is further away, and we decided we would include the cost of gas. But strictly going on the price, he's going to save over $5 if he goes to Home Depot. All right, the next problem. I'll just read it to you, then I'm going to give you time to think. So the basketball coach wants her players to dribble around the key and the top arc. So really come down here, across there, up there, and over like that. Greg has calculated the perimeter as in here. What errors, if any, has he made? And again, I'm going to pause so that you can do some thinking, and I'll also do some work. All right, so taking a look here, this is definitely 2L plus 2W. So we're definitely going across 4.57 twice. That's definitely happening. But we're only going across 3.66 once. So this should read, this is incorrect here because that shouldn't be 2, there should be one of those. So the correct calculation is 9.14 plus 3.66, which is 12.8. And this formula here, 2 pi r, is for going all the way around the circle, but we're only going halfway around that circle there. So I'm going to have to divide this by 2. So I'm going to take 22.98, divide by 2, and I will now get 11.49. And then the perimeter should actually be 12.8 plus 11.49, which is 24.29. So the mistake Greg has made is he included this, and he included that when they shouldn't be included. All right, next slide. So if we've determined now that this is the total perimeter, that if you're, or the total distance that you're going to travel when dribbling around the key, a coach wants the players to go around this 8 times, but Elizabeth is recovering from an ankle sprain, so she only has to do 75% of that distance. How far will she be dribbling? Now, I'm going to pause so that you can think about it, and I'm also going to be thinking about it. Okay, we're back to discuss how this one would be solved. Again, from this slide here, we've determined that just to go all the way around the perimeter, the outside of the key there, and across the top, that was 24.29. Okay, so I have to go back and edit and add an edit into this movie. Turns out you couldn't annotate any longer in YouTube. So this part up here was correct. Initially it said 2L plus 2W, but that shouldn't be a 2. It should be 2L plus 1W. So let me come into here. Let me delete that. Let's fix this. What we really need is 2L. I'm going to copy this. What we really need is 2L plus 1W. There we are. So that bit was correct. It should be 9.14 plus 2.66. That's 12.80. But I failed to recognize there's another mistake over here, the radius. The radius is not 3.66. That's the diameter. So the first thing I'm going to have to do is calculate the radius. 3.66 divided by 2, that's 1.83. And the formula we should be using here is just pi r now. So this here is pi times r. We don't want 2 pi r because we only want to go that far. And so 3.14 times 1.83 is 5.75. When I add 12.8 to 5.75, I get 18.55. So that should be the correct answer. The coach wants him to dribble 8 times. So 8 times 24.29 is 199.2 meters. But Elizabeth's not required to go the whole distance. She only has to go 75% of the distance. And remember, that's 75 out of 100. And that's 0.75. So 0.75 times 199.2 gives 149.4. So Elizabeth only has to travel 149.4 meters. All right, let's see where we are. What's next? All right, so one slide left. This would be, I guess, the exit slip if we were meeting face to face. So the first thing I want you to do is, you're going to pause this video in a second. I would like you to identify any line segments here who you think the number on that line segment really isn't reasonable. We're going to try and target, right? So he was given this. He looked at the diagram and said one of the measurements couldn't be correct, right? And I'm asking you to think about which one could not be correct. And so that's where we'll start. Think about the one that's wrong. All right, hopefully you paused that recording. If you didn't, you can pause again now. So I'm going to point out the one that looks really unreasonable. 70, then 160 would be longer. 150 and 160 should be close. This does look a little bit longer. 100 looks like it's longer than 70, but then take a look at this number here, the 40. That can't be right, because this line segment here is shorter than this one. How can that length be longer? So that's the one that's wrong. Now I would like you to find the correct measure. Now I'm not going to finish this one off for you. I'm going to suggest if you don't want the hint on how to get started, you stop the video and do some work on your own at this point in time. Alright, so what I'm going to suggest we do here, and because I'm having trouble drawing straight lines. Alright, I want a line to come up here, and then one to right there, so we went too far, so I'm going to have to shrink this down a bit. Pull that down to right about there, and that to there. There we go. Alright, so now I've been able to create a right triangle. There is a right triangle right here. So this is the hypotenuse of that right triangle. That's where the 40 is, but we know the 40 is wrong. So I'm going to put an X here now. And then we're going to try and figure out how long this is. Well, this length is 100, and this length is 60. So this length would need to be 160 minus 100. And this length is 70 from there to there. This length is 150. Man, very difficult on the trackpad to draw a straight line. So this is 1. What? Just ignore that. This should be 150 minus 70. There we go. That was a lot of difficulty writing all of that out. So then you could simply finish that off. Maybe I'm going to draw this over here just so that we can see what we have. Right triangle now. That's X. This is now going to be 80. And this is going to be 60. And then you can use the Pythagorean theorem to finish that off. And what you'll see is you should be getting something back that is at least greater than 80. I'm going to let you finish that one off on your own because it was an exit slip. If you want to see the solutions, they're online, and if you have trouble following the solutions, you can always contact us. So that's going to be the end of today's video. Thanks for watching. My daughter keeps reminding me to be a true YouTuber. I'm going to have to tell you that you should subscribe. And I guess click on the bell icon. I really don't even know where that is. So you can get notifications of further things that I post. And apparently I'm also supposed to ask you to smash the like button. So please do all of those things and enjoy the rest of your day.